Okay, so you don't have to write this down, can if you want, but just as a quick review before we start these word problems, we looked at problems like this. Remember? And we drew a number line, and what did we put in the middle of the number line? -5.
-5, -6.
And then we counted 6 both ways. This is review, we're trying to remember this. So then we said, okay, if we start at -5, the opposite of that number, and we go forward 6, we would be at 1. And if we go backward 6, we would be at -11. We colored in those dots because of the or equal to. And then we figured out if we need to shade in between them or outside of them. So we looked at this sign right here. It's a less than, so we're going to shade in between. So the answer to the problem was this. Remember doing that yesterday? Okay. We also looked at ones that look like this. Now we did those differently. How did we start these? Factor. Okay, let's see if we can get this right. How does that factor? Oh no.
X plus 5, X minus 1.
I heard X plus 5, X minus 1.
No.
I see some no's, I saw some nods. I don't know. I'm going to check it. If I foil this together, does that give me what I needed it to be?
No.
No. So this is not going to be the right factoring. Anybody have a different
No,
idea?
X
Probably a
plus
1 and 4.
X plus
Probably a 1 and a 4 maybe? Will that give me the right thing when I foil it? Listen, if you miss this problem because you factored wrong, it's just because you're too lazy to check. You can check, yes, until you finally get it figured out. This is right. So I'm going to draw a number line. Again, 2 dots on the number line. Where will these dots be? -4 and -1. And I'm very careful about where I put them. They need to be in the right order. And then I look at my problem and it's a greater than. So I'm going to leave the dots open. And since it's a greater than, I'm going to shade out. So my answer is, remember this is negative infinity. So negative infinity to -4. And -1 to infinity. All right, that's review. Okay, that was pretty easy yesterday. All right, so now number 3 on the back of page 6, number 3. A ball is thrown off the top of a building. So if we're visualizing it, here's our building.
We need our calculators.
Let's get them out. We might need it, yeah. Now we're not going to graph it though. A ball is thrown off the top of the building. The building is 12 feet tall. Here's the building, 12 feet tall. The ball is thrown up into the air and it's going to come back down and hit the ground at some point. Would you agree with that picture?
Yes.
All right. We have this formula, which you do not need to memorize. I will always provide you with this, although those of you that have taken physics probably already know it. But let's talk about it. This is called the projectile motion formula, and it is good anytime we're operating in feet. Meters will have a little slightly different formula, but this is one for feet, so we're measuring our distances in feet. T is the time in seconds. So every T I see is a time. Anybody know what this means? This is V sub naught. That's a 0. V sub naught. Anybody know what that means?
This is the velocity
Initial velocity. Very good. Are you a physics student? Yep. That's your initial velocity. So that is when I throw a ball, it's how fast it's going when it leaves my hand. It's initial velocity. S sub naught, and this is, S is the letter they use, but it's a little bit, it'd be easier if it were H, because it really means the height. S is the initial height. So for our problem, obviously we're throwing the ball from the top of the 12-foot building, so the initial height is 12. And then this is function notation. This means the height at time t. So it's like the y value. How high is the ball after 1 second, 2 seconds, 3 seconds? How high is the ball? So question A, well, first of all, let's write our formula. We're gonna have one of these on your test, and the first part of the question is gonna say, what is your formula? So for our problem, our formula is going to look like this. What is our initial velocity? 18. And don't forget there's a t there. Sometimes that t gets lost. There's a t there, 18t. And what did we say our initial height was? 12. So this is the formula that we're going to use to do part A, B, and C. This whole problem is going to revolve around that formula. Okay? Now, question A. When will the ball hit the ground? So remember, we threw it up and it comes crashing down. Right there is where it hits the ground. It looks like there's more, but there's really only 2 variables in this problem. There's this, which is the fancy math way of saying height. So it's like y, how high are you? And then there's t, which is just the x variable. So there's only 2 variables in this problem. This means height, or y, and this is x. Every one of these problems, A, B, and C, they're going to give you either y or x. You're going to know one of them. So read question A again and tell me, which do I know? Do I have a y value? Do I have a height? Or do I have a time? I have a y value. Why do I have a y value? Where is the ball?
12 feet.
No. When does it hit the ground? Where is the ball? On the ground. And if it's on the ground, how high is it? 0. So for part A, the height is 0, and I am going to solve this equation. A clue is, the question says when. That's time, isn't it? So I'm looking for the time. Therefore, I don't know x, but I do know y. That ball is on the ground. It's 0. Its height is 0. Okay,
I'm a little confused why it's at 0.
because the ball's on the ground. This is your height variable. If the ball's on the ground, what's its y value? What's its height?
Okay.
Yeah. I don't know what the x is there, but it's something comma 0. So I know y is 0. And now I'm going to figure out the x. Okay, the x is going to tell me when. So what do you want to do with this? This is a nice little quadratic equation. Actually, not very nice. But what would you like to do with it?
Subtract the 12
Factor.
Okay, so if I subtracted the 12, that would mean I was preparing to complete the square, which I could. But remember, I also have to divide by 16. Mess. I don't want to do it. Could you do it? Absolutely, but it will be a mess. Somebody said factor. Let's divide everything. What can we divide by? 2, I think, is it, right? Let's divide everything by -2. And maybe it will factor. I don't know. Let's see. 0 equals 8t squared minus 9t minus 6. Well, I'll just check real quick to see if it factors or not. That would be amazing if it did. No, it doesn't. So, I'm too lazy to complete the square. It doesn't factor. So what am I left with? Quadratic formula. All right, so let's do it. I love my picture. I really need to see my picture. I'll do it over here. T equals, all right, what will negative b be? 9 plus or minus the square root of 81 minus 4 times 8 times negative 6. Remember, A is 8, B is negative 9, C is negative 6. All over 16. Now, I have absolutely no idea what this works out to be. I'm going to type it in my calculator. And I got 273, but I'm going to have to wait and see if somebody else gets that. I did all this right here and got 273. Did anyone else get that? Guys?
How do you get 81?
B squared. Formula is B squared minus 4AC.
With that, like just with A right there, where did the negative 2 come from?
I just divided everything. It had, there's GCF. And it's just gonna make my numbers smaller. I don't have to do that, but it means I'm gonna have bigger numbers up here to try to deal with. So when I have a GCF, I like to just get rid of it, but you don't ever have to. All right, let's figure it out. T is gonna be 9 plus the square root of 273 over 16, or it's gonna be 9 minus the square root of 273 over 16. Does everybody recognize 2 answers there? All right, let's type them in. Be careful. 9 plus the square root of 273 equals divided by 16. You have to hit equals after you type in your numerator. Did you get 1.595? That's what you need to get. If you didn't get that, try again. Charlie, you with me, honey? You gonna type with me? There we go. Math is not a spectator sport. Alright, let's type this one. This is going to be the same thing, only it's going to be 9 minus the square root of 273 equals divided by 16. Negative 0.470. Is that what you got for that one?
Oh, I know. Yeah. I get it.
Now, let's talk about this. One answer. Luke, where's your calculator?
Oh, it's in there.
Come on, you just heard me yelling at Charlie. He's still back there digging around. Do you have it, Charlie?
I think I do, yes.
Geez, I think I'm in freshman resource again. Now, I got 2 answers. This is when the ball is on the ground, right? This makes sense to me, 1.595 seconds. The other one is back here. It's a negative answer, it would be back here. And that's okay, but is it really part of my problem? No. So the only answer to part A is 1.595 seconds. When is the ball on the ground after 1.595 seconds?
Could you get that answer by plugging it into your calculator and doing like the count trace?
Oh,
and
absolutely.
plugging it?
Absolutely. We could do this graphically. We could do this graphically by just going ahead and typing in our equation and then looking for a zero. Isn't that what that is? That's a zero. And it would say the same thing.
Yeah, why don't we just do that?
Well, a couple of reasons maybe. We need practice doing the actual math. And sometimes we don't get to use the graphing capability of our calculator, right? So sometimes I'll throw these little puppies at you. Okay? And when I say, okay, here's your calculator today, then graphing's not gonna be an option. So, is it good to know both ways? 100%. 100%. It's good to know both ways. All right, and maybe, I know for sure there's gonna be a problem here. Maybe when we do this second one, we'll do it graphically. But we're gonna do this with algebra.
595 back into the original equation.
I didn't, but I could. But if I did, if I plugged it back into the original equation, I'm gonna get zero. Because that's how I solved it. That is the value that gives me zero. So I could check my answer that way. Put it in here, and that should all work out to be zero. Because of the round off, it might turn out to be, 0.0053 or something like that. And it should be really close. All right, question B. When will the ball be 15 feet above the ground? When will the ball be 15 feet above the ground? Now remember, this is our equation for the whole problem. Y is height, so Y is feet, height. T is time, seconds. So read the question, when will the ball be 15 feet above the ground? What did they give me? They gave me Y. They gave me 15 feet. So 15 equals negative 16t squared plus 18t plus 12. When the ball was on the ground, the height was 0. Now the height is 15. Okay, so this is question B. So where do I go from here?
You subtract.
I could get my equation set equal to 0 by subtracting 15 from both sides. So negative 16t squared plus 18t minus 3. Huh? I don't think there's a GCF this time. So I'm stuck with those big numbers, those big numbers there. I'm stuck with it. All right? Now, we did the first one algebraically. So if you want to do this one graphically, we can do that. We can do that. What equation am I putting in? This guy right here, right? So negative 16 x squared plus 18x minus 3. remember, if you're choosing to do it graphically, you gotta be able to do it. So when I type that in, I don't know how you have your windows set, I use just a standard window. I got some like teensy weensy little parabola. I changed my window. So again, those of you that want to do it graphically, you have to figure this out for yourself. Right? I'm not gonna coach you through every problem. You gotta figure it out. If you're gonna graph, great. Figure it out. I changed my window. So X min was 0 and X max was 2. Keep in mind, I already figured out it hit the ground after 1.5 seconds. So this ball is not in the air very long. So I said, okay, my maximum is just gonna be 2. And then for Y min, I left those at -10 and 10. I didn't change those. Now, try graphing now, and you should see a picture that looks like this. If I'm doing it graphically, what am I looking for? That point and that point, because that's where it equals 0. So now I'm going to find those 2 points on my calculator. So second calc 0. Remember, this was your idea. I'd have been done by now with the quadratic formula. Just a second. So this one is 0.203. And this one is 0.922. Now I'm going to do this with the quadratic formula for those of you that didn't get it graphed. You do need to know how to graph though. So you need to get that worked out. But why were there 2 answers? I got 2 answers last time, but I threw one of them out because it was negative, remember? Why are there 2 answers this time? They're both positive. Are they both answers? Do I get rid of one? What's going on here? Can anyone tell me? Let's go back to the question. What was the question? What am I trying to figure out? When is the ball 15 feet above the ground? So let's look at my picture. This was 12. So wouldn't 15 be like a here? Look here. Aren't there 2 times that the ball is 15 feet above the ground? Once on the way up and once on the way down. So this question B actually has 2 answers. It's 15 feet above the ground after 0.2 seconds and after 0.922 seconds. It's 15 feet above the ground twice. Once on the way up and once on the way down. Okay. If I use the quadratic formula, here's my equation. So I have -18 plus or minus the square root of 18 squared minus 4 times A times C. Boy, there's a lot of negatives there. All over 2A. So I'm going to figure out what that is in there. So -18 plus or minus the square root of 132 over -32. This is just, I'm doing the same problem. I'm going to get the same 2 answers. I'm just doing the quadratic formula. So negative 18 plus the square root of 132 over negative 32, and negative 18 minus the square root of 132 over negative 32. Negative 18 plus square root 132 equals, divided by negative 32 is 0.203. Looky there. Negative 18 minus the square root of 132 equals, divided by negative 32, negative 0.922. So I did that one both ways. When is the ball 15 feet above the ground? So we let y be 15 and solve that equation graphically and algebraically. Two answers, because there's twice when it's 15 feet above the ground. And then question C. Probably the easiest one. How high is the ball after 1 second? Remember, here's your formula.
Replace the two with one.
Bingo.
Oh, yeah.
Remember, height is feet, time is seconds. They said 1 second, so you're gonna put it in for time. So after 1 second, you have negative 16 plus 18 plus 12, because 1 squared is 1 and 1 is 1. So it looks like it's 14 feet above the ground after 1 second. That makes sense to everybody? Well, I know it's a little challenging. We're gonna do another one. Just like it. Number 4 is just exactly like it. So let's see if we can make sense out of this. Alright, so here's our formula. Remember, you do not have to memorize this. I will give it to you every time. Alright, let's write our equation. What would be for this problem? Y is going to equal negative 16x squared plus what? 32 t or x plus 0. So I'm not going to put anything on the end. How come I'm not putting anything on the end? It's on the ground, and if it's on the ground, it's like if you put a football on the ground and then kicked it, the initial height of the football is 0 because it's on the ground. So 0. So this is our equation. I'm not trying to confuse you. You can call this S of t, and this t, it's the same equation. This is feet, this is seconds. So, what does A say? When will the ball hit the ground? So what do I know? Actually, let's not till we start solving it, but yeah, I think that she says, is this one factorable? Looks like it might be, but let's set up problem A first before we start messing with the formula. What is our A equation going to be? When will the ball hit the ground? You're going to put a number in for feet, or you're going to put a number in for seconds. Which one are you doing? The ball is on the ground. Feet would be 0. So you are going to have this equation if you leave the t's. If there are x's, it doesn't matter, whichever you work with the best. Now, Jordan says, I need to solve this equation. Can this one be factored? Yes, a GCF. What can I take out a negative 16t? What will that leave me with if I take out a negative 16t?
1 and 2.
A t and a minus 2? So when is the ball on the ground? What are my t values? T equals plain t, 0. Remember, when it's a plain t, it's 0. We did that yesterday on the number line. And the other one is t equals 2. Does that even make sense? Now wait a minute. Where does our rock start? On the ground. So the rock starts right here, and then somebody throws it up and it comes back down. Does it make sense that one of your answers is 0? Because that's where the ball started, right? And then again at 2. Okay. B. How high will the ball be after a half a second? Here's your equation. One of these, whichever form you like best. One of those is your equation. How high will the ball be? Solomon?
I have a question.
Yep.
How did you get 0 and 2 about the negative 16t that you like here?
Here? Remember, after you factor, you set them equal to 0. So negative 16t equals 0, and t minus 2 equals 0. So I solved them.
Thank you.
Yeah, it's a regular solving situation. It's nothing new and different. How do I figure out how high the ball will be after 1/2 second? Plug in 1/2 for the t, or x. I don't know, either x or t, whatever's easiest for you. You plug in 1/2. Or 0.5 if you're going to do it on your calculator. Maybe using 0.5 would be easier, I don't know. So go ahead and do the math and tell me what you come up with. How high will the ball be after 1/2 second? Yep, 12 feet, that's exactly right. Type it in on your calculator, don't sit there and stare at me. Don't say, did he get that? Type it in. And if you type it in exactly the way I wrote it, I mean exactly, you can't miss. If you'd rather use 0.5 instead of 1/2, that is fine also. Everybody getting 12? So how high will it be after 1/2 second? 12 feet. You will have to do a projectile motion problem on your test, and it's a really big deal, so you probably have to do it on your semester exam too. Alright, so we gotta get this figured out. Last question. When will the ball be 20 feet high? So if you come back to, here I have the formula with y's and x's. Here I have it with s's and t's, whichever you prefer. Here's our formula. When will it be 20 feet high? You're either gonna put a 20 here, or you're gonna put a 20 here. Which is it? 20 feet. It's gonna go here, right? So that equation is gonna look like 20 equals negative 16t squared plus 32t. And we're gonna solve this. Let's do it algebraically. We'll do it with the calculator. if we're gonna do it algebraically, that means like by writing things down, what am I going to do first? Subtract 20. So 0 equals negative 16t squared plus 32t minus 20. Then, if you want, you could divide everything by, actually, 4. Now, the reason I would do that is it's going to make my numbers smaller, so I'm not going to have those great big things in my quadratic formula. You don't have to do it, but it will make things a little more manageable. So 0 equals 4t squared minus 8t plus 5. Is that okay? Clearly isn't got a factor, so I'll use my quadratic formula. T equals, all right, here we go, negative b. Negative b,
Positive 8.
8, plus or minus the square root of b squared,
Negative 8 squared.
64. You're squaring it, it's going to be positive every time. Minus 4 times a times c, all over 2a. Alright, so let's see what we got under there. Things are not looking good here, folks. Did you get negative 16 under there? No? Leo, did I do that wrong?
So I got it.
I think 4 times 4 times 8 is 80. So I have 64 minus 80. Okay, so time out. Wait a second. When will the ball be 20 feet above the ground? And I am getting imaginary seconds. Explain that to me. Never. It doesn't get that high. So if I'm looking at, I picture 20s up here. When I throw that ball up, it doesn't make it to 20. So when does it reach 20 feet? It doesn't. And I know that because my answers turned out to be imaginary, and time can't be imaginary. Now, just for fun, let's go back to our original equation, negative 16t squared plus 32t minus 20. Type that in. If you change the window, you might want to zoom 6 just to get back to a normal window. And let's type in this equation and see what we see. Yep.
So, say that was like
I would put it doesn't get that high. That was literally okay, so when I put this into my calculator, in a standard window, so I zoom 6, so I was back to just a normal window, not a messed up one. When I did that, what I saw on my calculator was something that looked like this. Okay, now remember, this equation was set equal to 0. So what were we looking for? The zeros. And the zeros are the x-intercepts. Does my picture touch the x-axis? No, no solution. No. So graphically, it would look like this. There are no x-intercepts. Algebraically, it looks like this. I get a negative answer. Okay? Now, I'm going to hand out some practice work here. While I'm doing that, I want you and your partner to be working on another one of these. There isn't another one, I'm gonna give you another one. And I'm only gonna give you one question to answer. But I want you and your partner to figure it out. So I'm gonna throw a ball into the air from the top of a 50-foot building. The initial velocity is 80 feet per second. I want you to tell me, when does the ball hit the ground? That's gonna be a guaranteed test question. Let's see if you can figure it out. So, I have thrown a ball from the top of a 50-foot building. Its initial velocity is 80 feet per second. I wanna know when it hits the ground. And your formula for projectile motion is this. So, get started while I hand out some papers, and we'll come back together and see how we did.
I'm so confused. I'm so
Find a piece of paper or something. Scribble it in somewhere.
Can we write it here?
No, those are our next notes. Those are chapter 1 notes. So I would write it there. The chapter 1 notes are beginning on this page. I mean, on your notes paper, you just flow from one to the other. So you're gonna wanna keep this space. All right. What equation did you start with? What is your general formula? S of t or h equals negative 16t squared plus 80t, don't forget the t, plus 50. Starting with that, right? Then we remember that this is height and it is feet, and this are time and they are seconds. Every question will either give you a height or time, because you're gonna plug something in somewhere. When does the ball hit the ground? What do I know? Do I know a height? I know a height. If I'm on the ground, my height is 0. So your equation that you are solving looks like this. Everybody should have that equation written down. That's what you're solving. Now, at this point, we can diverge a lot of different ways. I might look at that equation and say, well, the best I can do is dividing out a -2. You may decide to do that and you may not. It doesn't matter. I'm gonna go ahead and do it because I don't like a negative there. So I have 8t squared minus 40t minus 25. I'm dividing everything by -2. You do not have to do that. Does everyone understand me? Are you hearing? You don't have to do that. So now, some of us might try to graph this. And if you graph it, remember, you will be looking for where you cross the x-axis. Zeros. Some of you may say, okay, I'm going to use the quadratic formula. So b, negative b, plus or minus the square root of b squared, minus 4 times 8 times negative 25. These are big numbers. But I don't care because I got a calculator. Again, you might be graphing it. You're looking for x-intercepts if you graph it. So I got the square root of 2400. Anybody else get that? Underneath that radical? So then I'm gonna do 40 plus the square root of 2400 divided by 16, and 40 minus the square root of 2400 divided by 16. 40 plus the square root of 2400 equals, gotta hit equals, divided by 16. I got 5.562. Anybody else get that? When does the ball hit the ground? After 5.562 seconds. All right, what's that one? 40 minus square root of 2400 equals, divided by 16, negative 0.562. Seconds? Negative? Do I want that one?
No.
Can't have negative, throw it out. Keep in mind what's happening. What's happening is the ball started up here at 50 feet. You threw it up in the air and it came back down over here. If I continued, it would be back here, but the ball was never back there. That's negative time. That's before I threw it. Huh? That was this is when it hit the ground. So the answer is 5.562. You cannot afford to tune me out because I'm doing a word problem. Can't do it, guys. You gotta know what's going on here. Alright, so we'll practice some more. But here's what you have in your possession right now. First of all, the next part of your note says 1-1. That's chapter 1. That's where we're going next. So hang on to this. But there are extra problems here from section P5, which is the solving. And there are properties and property practice also attached to those. That's for you. Not assigning any of it, it's there for you. What I handed out, and everyone should have a copy of, are the 3 practice tests for this unit, this chapter. I want everybody to look at the first one. All right, so get your practice test packet out. See how it says up here, practice, or Precal C, practice test P number 1. And then I want you to look at how it's set up. You see how it's got directions like solve, and then it has problems, and what's over here, answer blanks. And then you turn the page, and oh gosh, there's some more, and then there's some more, and then there's some more. Then all of a sudden, we are at practice test 2. So these 2 pages right here, the first 2 pages, that's practice test 1. Guess what that looks like? Your test. Exactly. 2 pages front and back, same number of questions. My order might be different, same directions, and then look at practice test 2. You'll notice when we start doing these, it is exactly like practice test 1. And then practice test 3 is exactly like the other 2. So next class we have, is that tomorrow? No. Monday? We're going to start practice test 1. And as soon as we're done with all three of them, we're gonna go through them in class. As soon as we're done with all three of them, it will be tested. And so help me God, if anybody acts bored when we're doing this review, we'll stop doing review. This review is for you. I'm going to get an A on this test. I don't wanna stand up here and do it 3 times. I'm doing it for you. So no yawning. No yawning, or we won't do it.
What is P7 do?
P7 is due on Monday.